Okay, so if you haven't already picked one of these up, so you don't have to flip to the back of your book, there's some charts for the normal distribution. Maybe you want to grab one of those. Just so you don't have to keep flipping back and forth. All right, so again, we're doing normal distributions. Normal distributions are on this bell curve. And what goes right in the middle of that bell curve? The average, right? The average goes right in the middle. What's the average for this problem? The mean duration. So again, the mean is the average, and they're saying that it's 12 days. On average, you have to suffer for 12 days. So 12 goes right in the middle. Now it says that the standard deviation's 3 days. So if I had a z-score of 1, that would have 15 days. A z-score of 2, that would be 18 days. You guys okay with that? Z0, 1, and 2. What if we go the other direction? What if we go the other direction? Negative 1 for a z-score, that would be how many days? Good. And then negative 2 would be 6. Okay, because we're counting by threes there. Beautiful. So I want you to just estimate, like, what do you think the probability is for longer than 17 days? I mean, if the average is 12, that means 50% of the data is at 12. Where would 17 days be? Quite far to the right, yeah? Over here somewhere? Okay, now do we shade to the left or to the right for this word here? Longer than 17. Shade to the right. You guys agree with that? Is that a very big part compared to the whole? So we should expect a pretty small probability here, right? So what we need is to find the area for the z-score of whatever we get from 17. Okay? So this is where we got to go use this formula. Z equals x minus the mean over sigma. And there's only a few of you that I looked at your quiz. You're not putting this in the calculator properly. So in our case, what is x? 17. What's the average? 12. And the standard deviation is 3. There's only a few of you, and he's not even here, so that's great. Yeah, you got to do the top before you divide. So don't do all this in one step. Do it in 2 steps. 17 minus 12 is 5, and then 5 divided by 3 is 1.6 repeating, so this would be 1.66 for the z-score. So now, that's where you switch gears to this guy. Do you need a chart? And then you got to find the area that matches the z-score. So 1.66. I'm just going to wait till everyone else has looked at it because I don't want to be just writing down notes if you guys don't get what I'm doing. Find it, please. Like, look on this sheet. Go find 1.66. 9515, right? 9515. Mr. Dixon, you got a chart? My man, you got a chart? That way you don't have to fly back and forth. Yeah, 9515. So 9515, what would the percent be for that one? I thought we were looking for something really small, weren't we? Good, so you have to subtract from 100%. Okay, so it's about 4.85%. Or you can subtract from 1, she's correct. 1.00, take away 0.9515. Either one of those will suffice. Am I correct on the whiteboard? Okay, so this z-score gave us an area of 0.9515. So we did 1 take away that to get the other piece. 0.0485. Please someone just confirm that. Okay. So why do you subtract from 1? Because everything in here represents 1. Yeah, everything represents 1. So if you just subtract the stuff on the left, you get the stuff on the right. The chart gives you the stuff on the left, right? The chart gives you the left. Okay, so let's do 13 and 15. And I'm just going to use the same one here. So this is roughly where 13 is, right? So if I found 15, it would give me all this, correct? If I found 13. 15's over here somewhere, right? So if I found 15 on my chart, it would give me all this, right? So how do I get just the in-between? Yeah, because this is all we care about, right? That's all we care about, the little section. So if you had the z-score for 15, you could find all this area, correct? And I need to make a lot of that space white. I need to remove that area. How do I remove that area? Good. Find the z-score for 13 and subtract this out. So find 13 and then remove all this. And then you're left, this is the remainder. I don't think that's a good word to use. This is left over. Okay. So what's your z-score for 13? 13 take away 12. What's with my pen today? Take away 12. Sigma's 3, right? So I got 0.33 for a z-score. And if I used 15, three divided by 3 is 1.0. So you got to find the areas for those two. What's the area for 0.33? Where's my sheet? .33 6293. Okay, good. Okay, and then for the other one, z-score 1.0. Who said that? Good job, Proto. I put the big one on top and subtract. Say that again for me. 0.212. Gorgeous. So this is the answer as a decimal, and to get the percent would be times by 100. Very nice. So 21% of the data lies between 13 and 15. So hopefully you're getting good at these ones. Z-score to the left, that's pretty basic. Z-score to the right, you got to do a switch from 100. And then Z-score for in between, you got to do area big, take away area small. Those three, I bet if you could memorize those, you're going to do good. Okay? You're going to do well. Can I slide? Okay, now these questions on the back are a little bit more challenging, so please pay attention, as they will stretch your imagination a bit here. Okay, so from some extensive testing, this appliance company, so they sell toasters, they sell toaster ovens, okay, making toast. They found that the average life is 4.2 years. That's how long these things last. Well, that's a good investment, right? Where does that go on the image? In the middle. Yeah, it's not good. So then the standard deviation is 0.65 of a year. So take your calculator and add 0.65 to 4.2. And you get the next one. The next one is 4.85. And then add 0.65 again. And you get the next one. Okay? I really like to do this with whatever data I'm given because it helps me to visualize the answers that I get. Do they even match to the picture? So start at 4.2 and let's subtract 0.65. Then I got 3.55. Do it one more time, subtracting the standard deviation, and I get 2.9. That way now I can analyze it. So like, let's say my toaster only lasted 3 years. Am I below or above the average? Yeah. So I'd be somewhere over here. What if my toaster lasted like 7 years? I'd be way over here, right? My toaster's better than like every other toaster. Mine lasted for 7 years. Okay, anyways. Let's take a look at what the company wants. Question? No, the z-scores will always be for this curve. Yeah. It's a good question, though. So, the company, guys, does not want to replace, under warranty, more than 8% of the toasters that are sold. Just think about that for a sec. If they have to replace on warranty, they're losing money, right? So they only want to replace at most 8% of the data. 8% of all toasters. 8% is a probability. 8% can be written as a decimal. 8% is the area. Yeah, very good, Olivia. She says they're giving it to us backwards. You got to work backwards to and then get the z-score from the area. So now you got to go look at this chart and find 0.08. No. 0.08. I got like negative 1.40. You're looking for an area and then finding the z-score. Mr. Keaton, please put that away, sir. Awa, put your phone away, take your headphone out, or you'll find yourself somewhere else. You're not dumb, you're just learning to use it for the first time, so please pay attention. We're looking for an area. And I found it way over here, 0808. It's right here, 0808. That's the closest one I could find. Or you could do 0793 because that one rounds up. So negative 1.4. So now you start in the chart, and then you got to find the z-score, not the other way around, right? Yeah. Yeah, we're trying to find the z-score for this percentage of data. Because remember, the percentage lies inside the curve. So what z-score is for 0.08? I got negative 1.41 or negative 1.40. Either one of these is fine. Either is fine. Okay? So if that's the z-score, how many years would that appliance last if it had that z-score? Okay, so z equals x minus mu over sigma. I know the z-score is negative 1.4. We're trying to find out how many years it's going to last. This is where they get challenging, because not only do you have to perform algebra, and you have to work backwards on the chart. Do you remember this one, Ryan? Cross multiply, good. So we'll times both sides by 0.65 on both sides. Okay. Well, you have to unlock the numerator by cross multiplying. 0.65 times negative 1.4, I got 0.91. And it's negative 0.91 x minus 4.2. Now how do we solve for x? What's the opposite of minus 4.2? Okay, add it to both sides. And you solve for x. 3.29. Okay? So they should pretty much offer like a 3-year warranty. That's what they're saying. This company should offer a 3-year warranty. Or maybe even like, if they wanted to be really careful, they'd go for a 4-year warranty. Like save money, right? Yeah. 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 Is that you? Guys, put your phone away. Trinity, put it away. Okay, let's go to the next one, guys. Focus on me, please. Knack. Okay, here we go. It was found that about 60% of the shrimp harvested at this shrimp harvest farms has a mass of more than 135 grams. All right. Does it matter that it's about shrimp and the shrimp company? No, it could be any context. All you need to think about is this 62.3%. Is that a z-score or is that an area? Area. So from that area, we could work backwards to find a z-score. Okay? And then the 135 grams is what we're interested in. If it was a company, maybe it's about years. If it's about a football team, maybe it's about weight. If it's about a basketball team, maybe it's about height. If it's about a hockey team, maybe it's about goals. It's totally just whatever they're talking about in the context. This case, shrimp, they have a certain mass. We want to weigh them. Okay. It's normally distributed. That tells us it's this chart. Okay? This chart. The average, that's what it says, mean, average is 146. Where does 146 go? Boom. Determine the standard deviation. Oh, I got to find the standard deviation. How could I find the standard deviation? Rearrange formula. I'm trying to solve for this. So Ryan said on the last slide to cross multiply. Is that going to work here as well? You could just do a switch. So yes, it is okay. Basically, this cross multiply switch, they switch places. It's like, okay, times by sigma on both sides. Okay, divide by z on both sides. And that's where you end up. Times by sigma on both sides, divide by z on both sides, and it's just a cross multiply switch. That should be part of one of your tools in your algebraic skill set. So all I need is x and mu and z, and I'm happy. Do I have x? What's x? The 135. Somewhere over here is 135, correct? So I need the z-score for this guy. Now we have to go into the clue for the question. How is this area going to help me? First of all, 60%. Well, 50% halfway. So this is more than 50. Do you agree? So am I shading to the right or to the left? Look at this key word here. More than 135. So then we shade to the right. So this shading has an area of 0.623. Do you agree with that? Because you slide the decimal 2 places. So then in my blue pen, what's this? Yeah, 1 minus 0.623. You got 0.377? Try to find this on the chart now. Find in the chart. And you might not find it, but you got to find one close. I got negative. It's on the negative side. 0.3 what? This is what I got for a z-score. I used 3707. Oh, that's not a good. I screwed up. Do you think I screwed up? I think I screwed up. There's a better one, right? So 3745, 3783. I like 3783 actually. So right here. How about that one? Better? So it's on the negative side, and I'm scanning this chart looking for 0.377, 0.377. Oh, here's a 37, 374, 378. So it's right here. Negative 0.32 or negative 0.31. Either will work. Okay, and then you just solve this formula. 135 minus 146 over negative 0.31. That solves for sigma. Make sure you do the top before you divide. 135 minus 146, I got negative 11. Divide by negative 0.31. And a negative divided by a negative will be positive. So I got 35.5. It says nearest tenth. There's sigma. 35.5. So that one's tough. And as you probably have noticed from this workbook, they get progressively harder. Question 1 versus question 5, usually question 5's harder. Okay, one more to go, and I'll give you guys some time to work, and I'll hand back quizzes. Don't change it yet. Alright, let's take a look at class example 5. Okay, let's take a look at this one now. You see the marks of a big group of students. Okay, focus back on me. Okay, so a whole bunch of students wrote a test. That's like the province, all these kids in the province, they write a diploma. It's the same sort of idea. Okay, the data is represented on a normal distribution curve, and the values given represent the actual number of students, not the percentage. Okay? So how many students are represented by the area under the normal curve? I want you to think about this for a second. What do you know about this section of the curve colored in blue? What percentage is that? So 50% is 1250 in terms of number. So what would 100% be? Yeah. You guys see that? If half the population is 1,250 students, what's the full population? Right, Steph? All you would have to do on both sides is times by 2. So you get, this is the total number of students. So how many students are represented by the area under the whole curve? Well, that's 2,500. We already answered that. Part B. Determine the value of the z-score at Z1. So again, if you were to find this one on the chart, which area would it shade? To the left. So if 2,500 is your total and you have 452 in that section and 1,250 in that section, how would you get this missing section? Yeah, minus those two. It's no different than, remember like the angles on a triangle and you had 2 of them? How do you get the third one? Subtract from 180? It's the same idea. There's 3 sections that represent 2,500 and you have 2 of them. So you just have to subtract off the other 2. So 2,500, take away 452, take away 1,250. What does that give you? 798? Okay. 798 what? Sheep? 798 donuts? Students. Okay, 798 students. But we're trying to find Z. A z-score has a certain area or a certain probability attached to it. So what would the probability be for 798 students out of a total of 2,500? You have to find that ratio. Find this ratio, and that's the percent that you're looking for. 798 out of 2,500, 0.3192. You have to look in the chart for that guy. So now I'm looking for 0.3192. Oh, that one showed up perfectly, right? Negative 0.47. Good. Okay. So this assignment, you've already should have gotten some of it done because we've been chunking it away piece by piece. So this 1 to 12, you already should have some of it done. Let's try to finish the rest of it. I'm going to walk around handing back quizzes. Do you have a question? Okay. Did you get the same answer? Okay, I'll come look.